Here we go. Welcome back to Containers on the Couch on the AWS Twitch. If you're not familiar with the show, this is the place where we get to talk about all things containers on AWS and talk about some of the latest launches, talk with some of the folks who are building the products to make containers on AWS better. And I've got three amazing guests with me today. Kick it off. Why don't you start, Arvind?
All right, sounds good. Can you hear me?
Yes, we can.
Awesome. Thank you for joining us, folks. My name is Arvind Soni. I lead our team of containers specialists here at AWS. Myself, been here for about 3 years, focus on ECS, Fargate, all things related to serverless containers and such. But today we're going to talk about how do you allocate the cost when you run things on server, EC2 essentially. And with that, Shubir, you want to introduce?
Sure. Thanks, Arvind. Welcome, everybody. My name is Shubir Kapoor. I am a principal product manager. I belong to the cost management team within AWS, so partnering with the ECS folks on this call. And we're really happy to introduce this new feature that we've launched, which essentially helps you streamline and provide you more granularity and visibility to your ECS costs. I've been with AWS shy over 2 years now, so happy to be here.
Cool. Okay. Did I put my name wrong? Okay. My name's
is it misspelled?
Davis.
Oh, you can fix it. Don't worry. But go ahead and introduce yourselves.
Yes. My name is Wei Juan Davis. I'm a product manager of the ECS team. I have been with AWS for about 10 months now. So before that, I was a product manager lead in Azure with Microsoft. I work on Windows containers, and in Kubernetes and Azure Kubernetes. So I'm very excited to, with all the guests here, coworkers here, to talk about ECS and specifically on the cost management. I know this cost, it's one of the top interest area for customers. So I'm excited to be here. Thank you.
Absolutely. And you hit the nail on the head when you say it's a top issue for customers.
Yeah.
For many people, what drives them to consider containers in the first place is they look at the compute power of an EC2 instance, and we see these EC2 instances getting more and more powerful, bigger processors, faster processors every year, and it's just too much power for their application. Their application is not to the point yet where it has that many customers. So they say, how can I run multiple applications per host? Containers are where it's at. But now I understand there's another problem that happens, which is, how do I actually tell how much money I'm spending on each application in my cluster? So maybe, Schubert, it sounded like you had like a little introduction you wanted to talk about, what this problem is, how we can start to solve it.
Sure. Yeah. Do you want to share my screen?
Yeah, I'll bring it up.
Awesome. So, yeah, before we jump into talking about the feature, let's take a step back, talk about what Nathan just mentioned. And the industry term for that, as we move forward with this, is essentially cost allocation. So, what is cost allocation? So simply put, cost allocation is the process of splitting up your cloud bill and then associating the costs to an individual cost center. So you can look at it at any level within your organization. So it's important for customers to understand how their cloud costs are being allocated, and then obviously to have a centralized, a controlled, or a consistent cost allocation strategy. And then once you can allocate or split your costs, you then can engage in optimizations. You can do showbacks, you can do chargebacks, depending on your business process or your financial accounting strategies. So essentially, cost allocation drives accountability and enables the opportunities for cost optimization within your organization. So
this would be like multiple teams within the same org, multiple business units. I imagine there's a number of different ways you might drive that depending on how your business is laid out, the structure of it.
That is correct. That is absolutely correct. And as you think about, so cost allocation is not specific to ECS. I mean, we will talk about specifically how this applies to ECS. But when you're looking at your cloud bill, right, you've got multiple teams, multiple departments, multiple regions spread across the globe, right? And they're all using the same resources. And you're trying to allocate those costs down to specific cost centers or departments. So we're going to be talking about a very specific use case today, specific to ECS, but the problem at hand, the cost allocation problem at hand, generally applies to your cloud bill, as if you will. So, what exact problem are we trying to solve out here? So, everyone can relate to the challenges of mapping your utilization or your cloud utilization costs to specific individual drivers. I mean, running applications in the cloud includes things like shared resources. So you got compute, you got storage, you got network, you got shared data lakes, you got shared file systems. And then take a specific example, which is what essentially we've solved and we've launched for. So take the example of you're running applications in a containerized world, and traditional cost visibility and mapping costs of resources back to teams or individual projects or individual cost centers. It's just difficult, right? I mean, you just can't allocate the cost of a resource such as an EC2 instance, for example, and then tag it or label it, because that resource could be, or that instance could be running multiple containers. Each container could be supporting different applications, as an example. And each of this could be associated with different cost centers or different departments. All right, and you want to basically understand, what is that cost of that instance, and how does it, allocate or charge back or show back to specific individual teams and departments. So, the problem we're essentially trying to solve is, trying to address what we're calling shared resource costs that result from the use of shared infrastructure. So again, back to the example, you use ECS. You're essentially paying for your EC2 instances. We call that our billing unit. But you're interested in costs at a much lower resource granularity, right? Which is the cost per ECS task, or maybe the cost per ECS service. And that's really just a proxy for your workload or your application. So, prior to this launch, these resources and their costs were not visible in the billing and the cost management systems, such as cost and usage reports and Cost Explorer. But essentially, post-launch, we're making this available to you through our billing and cost management systems.
Wow. That sounds super useful, because there's so many different workloads that have different scaling mechanisms. Some people are running batch jobs that's just like standalone tasks. Some people are running web services that scale up and down throughout the day. People are running ECS tasks on cron schedules, where maybe it runs like every hour or something like that. So a particular EC2 instance may be doing many different things throughout the course of a day, or even throughout the course of an hour. So I can imagine this is a very complicated job to track that usage and map that back to billing. So I'm really interested in seeing with more details about how this is going to work.
No. So let's jump into that. So how does it work? I mean, what is the feature and how does it work? So essentially, the feature is called split cost allocation data. We're calling it a new cost management feature, which essentially enables customers to analyze, to optimize, to charge back their cost and usage, specifically for containerized applications. We go by the acronym SCAD, split cost allocation data. So I'm going to be using that term repeatedly. So I just wanted to call that out. So using SCAD, customers can allocate, containerized application costs, and then allocate them back or show them back to individual business units or teams. And we essentially do this based on how your applications or how your workloads or how your services or how your tasks essentially consume shared compute and memory resources. So it's really based on utilization. It's based on actual usage or reservations of your compute or memory, that we actually then start allocating the cost of your EC2 instance down to an individual task or down to an individual service. So essentially what split cost allocation data does is it introduces new container level resources, essentially tasks. So the cost and usage on a per task basis starts getting available in the AWS cost and usage report. And the cost and usage report, if you're not familiar, really provides a detailed, granular view of all your AWS cost and usage. It's typically available as a CSV. You can also download it as a Parquet file, and it's delivered in an S3 bucket of your choice at least once a day. And then you can take that data and you can use Amazon Athena data integrations to quickly query it. You can also upload it to QuickSight. You can do some BI visualizations on it. Today we'll basically take you through a demo of how you'll go through creating a cluster, creating a set of tasks, running a set of workloads, and how do you actually make use of the data? Because once that data flows into your cost and usage report, what is the value that data essentially provides to you? So having said that, let me hand it over to Arvind to start talking about the demo and talk about next steps.
Sounds good. Thanks, Shubir. Nathan, are you sharing my screen? You guys able to see the?
Yeah, I'll bring it up.
You guys
All right, we're seeing the ECS console right now.
awesome, perfect. So yeah, as Shubir mentioned, right, like when you're running containers in a bunch of EC2 machines, a cluster or many clusters, what you want to understand is where are these containers coming from, what these containers represent, and most importantly, how much are they using, how much are they contributing to the cost, and how can you allocate it back to the teams that are firing off these containers, right? So in order to illustrate that, what I have is a bit of a simple environment, scaled down environment here. One cluster called core infrastructure. It has 5 EC2 instances running over here. As you can see, 5 of them. And they're a bit beefy instances, right? And this is just to illustrate that there can be a lot of waste going on as well.
How much CPU do they have? 4096, four CPU cores. There you go.
CPU, yeah. I promise I will turn it down after the demo. 4 vCPU and 16 GB RAM. Okay, and as you can see, there's a lot of it available. Some of it is quote unquote being used. Now, what is using this cluster? So as you saw earlier, there are 2 services that are running over here, and each of this service has 3 task replicas. Yeah. So total of 6 tasks are running, distributed in these 5 beefy instances, and they've been going on for some time, right? So now you get the bill and you look at the bill, and before this is split cost, what you would see in the bill is essentially just the cost of these 5 EC2 instances, right? You will see the pretty much the same bar, like you're paying for those 4 vCPU and 16 GB memory. So if you go to something like Cost Explorer, which is here, and I couldn't figure out how to get rid of this annoying blue thing. But if you
wait, it doesn't close if you press the X?
No, it doesn't.
Oh no, I'll have to file a bug right after this stream.
So before this split cost allocation, which is kind of like the current status for a lot of the customers, is you'll see this cost here, which is the cost of the instances, right? But then again, there are many teams that are using these instances at different capacity, and they're consuming different resources. So now the question is, how do you get granular insights into this? And that's what the split cost allocation enables you to do. Okay.
That's interesting, because another thing that I've seen is it looks like this is a statically sized cluster. It's running 5 instances. I've seen in some cases the bill skyrockets because it suddenly goes from 5 instances to 50. And now the question is, well, what service was it that scaled out that pushed this cluster to launch so many EC2 instances?
Exactly. Yeah.
And maybe people don't really know.
Yeah.
Well, we only have a very simplified version, but I kind of give you the idea. Yeah.
Exactly.
So this is driving accountability as well, right? So as soon as you know which team is spinning up the resources, and maybe the team that's spinning up the resources is also bringing in the money, which is great.
yeah, that's a good problem to have.
That's a good problem to have. But if it's the other way around, that's where the red flags need to go up.
So before you start using this feature, right, like of a split cost allocation, you need to make sure that in your ECS service, you have enabled tags, right? You have enabled tag propagation, and you have enabled ECS managed tags. Now, ECS managed tags are sort of out-of-the-box tags that ECS will attach to your tasks. They consist of things like cluster name and service name, right? Kind of useful, 2 fundamental ones that are useful. So if you look at, if you go to my CLI, and I just do a describe service on one of these services that is running, the ECS demo backend, and you'll see the parameters that I'm talking about that you should set up is these 2 here at the bottom. You need to enable the ECS managed tags. It will automatically add the service name and the cluster name. You don't have to manually do anything. Just enable this to true, and then set the propagate tags to service, which will tell ECS that every task that is spawned from this service as a part of the service will get these tags. Okay.
And I understand that there's other options here for the tag propagation. Like what are the other options for propagate tags?
Yeah, there are 2 other options. I think one is from the task definition. So whatever tags you have specified in the task definition, they will get propagated. And the other is let's just say don't use this. It's the default none. If you're going to define the tags, you might as well propagate it.
So I can imagine maybe task definition for those who aren't super familiar with ECS. Task definition is essentially a definition of one version of the application that you want to roll out in your cluster. So perhaps if I had tags per task definition, that would be a tag that specified the specific version of my application. I could see if one version was especially wasteful of resources compared to another version.
Yeah.
Wow.
Okay. So let's confirm that if you go to this ECS demo backend service, and if you go to one of these tasks over here, there are 3 tasks, as I said, running. Let's just click on one of them. And if you go into the tags section, there are some tags that I have added. This was me adding manually, app equals ECS demo backend. These 2 machine looking names, I don't deal with colons, right? These 2 machine looking names were ECS managed tags that are generated and propagated to the task. These other ones, you can have your own tags like cost center, for example. You can even associate it to the GitHub repos, another one that we see pretty often. Where exactly is the code coming from? So these 4 of them are created by me manually as a part of the service. These other 2 are created as ECS managed tags and propagated to the task. This is the first step. Now the task.
So let me clarify, when you say manually there, I could click that manage tags button and add a tag manually, but most likely I would code that into like a CloudFormation template or Terraform or something like that. Yeah. So I'm familiar with this ECS blueprints repo, so I know that came from Terraform. Yeah. It was as simple as in your Terraform, you specify the tags in Terraform, and Terraform added those tags to the service, which then the service propagated them down to the task. So it is manual in that you specify the tag name manually, but it is actually still very automatic in that infrastructure as code automatically added that to the service automatically added it to the task. So you manually set it up once, and then from there on, it's automated, which is pretty cool.
Yeah.
I think, and for the audience, like we have a GitHub, actually Arvin has GitHub, which have links all the prerequisites, so you don't have to write it down and memorize. We'll give you the link and the steps to show, where you can read more, where you can, how to do the configuration of the tags.
Yeah.
There you go. Yeah. So they're like
perfect.
Right? Enable ECS managed tags and enable propagate tags. And we put the value right here. And once you have added to the service and you've got the tags right, like almost halfway there. Now let's talk about how do these tags flow into the cost and usage report, and what other flags do you need to set up so that we enable the split cost allocation, right? So the first thing, so assume this part is clear. You got the service, you got the tags, you have enabled some automated tags. Most interesting of them is the service name, which will help you partition the cost by the service. Okay. So now let's come into the Cost Explorer, and this is just, you can type here AWS Cost Explorer and it will bring you here. And if you come to the preferences section in the Cost Explorer, you will see that there is hourly and resource level data. You can check this. So you will get the granular detail at the hourly per resource. In this case, the resource will be the task, the ECS task. So you will get the granular data for costing. And then this is the new feature, which is the split cost allocation data. If you enable this, then the backend machinery that Subir Stream has built will kick in, and they will allocate the cost of that big machine into individual tasks, which we will see how it looks. So you have to set these 2 flags over here. Yep. So far, so good.
All right.
Mm-hmm.
Now, the other thing that you need to do is, since you have done all the hard work of creating those tags and enabling those tags, you might as well tell the billing department that please use these tags. So if you come in here to your billing console, which is here in the billing dashboard, if you come to the cost allocation tags, right, this one, there are 2 types of tags. One, as you saw, defined by me, which had nice name, app equals ECS demo backend, or generated by the AWS service, like that colon type of thing.
Now, let me ask: are there any side effects to enabling these tags? Like, is there a cost associated with enabling a cost allocation tag?
No.
Not that I am aware of.
Okay,
No.
good confirmation from Schubert. No, yeah, because I see a lot of people, they wonder, like, if I create this resource, is that going to add something else to my belt? So good to know that this is all basically built in.
Yeah, the one thing that I did find is that if you are going to be dealing with CSVs, right? Like if you are in the Excel land and you're going to be working with Excel sheet, each one of these tags will become a column in your CSV file.
So I see you have cost allocation tags activated 78. So this CSV has 78 columns.
Yeah. I'm not going to open that one.
that's a lot of cost centers and teams, but I imagine maybe for some organizations 78 would be a low number. So just keep in mind, I guess, you're gonna need some very large data files to represent all of this.
Sorry, I was just going to say that's what the cost and usage report is, which is what Arvind will go into.
Yeah.
But essentially, the value that these tags bring forward is it's so when you look at your CSV file, you have resource level data, and you have how much a particular resource used and how much that the cost of that resource was. Yeah. And then along with that resource, if you've tagged that resource, so in this case, because we enabled it at the ECS task level, that task level resource will have this tag associated with it. So now when you're parsing through millions and in some cases billions of rows of data, and you really want to look at, okay, ECS demo, right? That's my application I wrote, and I want to ignore everything else. These tags give you that filtering capability to hone in specifically on an ECS based application, if you will, and then just look at the cost for that application.
Yeah. That's awesome.
Okay, so quick recap. You went into your cost explorer and you have enabled the split cost. You came into your billing dashboard and you have activated at least these two tags, which are automatically generated and propagated for you. So now you're pretty much set, right? Now the tags are flowing. And if you have the cost and usage report, if you haven't created one, you can create one over here. It's pretty straightforward. You can just come in here into cost and usage reports, hit create report, and most of you are familiar, so we're not going to go too deep into it. You can give it a name and S3 bucket and things like that. But make sure to check mark the split cost allocation data when you create this, and it'll include the resource ID that will give you the task ID, just in case you want to go granular into, oh, hang on one second, why did this spike up? It will give you the ability to associate it to the exact task that is spiking up. So when you create this report, just make sure that you add these two over there as well. Okay. The rest of it is fairly benign, like the S3 setup and CSV format and things like that. Okay.
And I see there's a checkbox for refresh automatically. It says that it'll, down at the bottom, it says it'll refresh the report at least once a day. When a new report refreshes, new reports uploaded to Amazon S3. That's pretty cool. So I'm setting up basically a live refreshing thing that I can then pull into my own systems and consume it however I want on a regular basis.
Yeah, let's see. Actually, I saw it twice a day. So I don't know what I did differently over there, but I did. If you go to my bucket over here, in the CSV report folder, CSV reports over here and here, you can see.
Oh, so there's a folder for each timestamp there.
Each timestamp is there, and if you scroll down here, see for 6:15, there is two ranges that are two reports. So same for 14, there are three sometimes. So this one I wonder, Shubhi, do you have any idea of how many does it get created, 2 or 3 or 1 a day or something?
Yeah, so we at least publish 1 a day, and then at most we can do 3 times a day. Okay. So it's anywhere between 1 to 3 times a day is when we publish.
Okay.
And so each of these is a snapshot of the split cost allocation from the time period of now until the previous report. So it's like a segment of the time period, or is it like a roll up of like the entire month?
No, it's a segment.
So it's monthly. So every report basically has a month to date, or every folder.
Oh, okay. Everyone is month to date. Okay, that's good to know.
Every folder will have a month to date for that particular month. But because these files can be really big, we split them into multiple files. So when you look at a single file, you might not have the full month. But when you look at the entire folder across all the files, you're always going to have a month to date for that particular month.
Got it. Okay,
that's really good to know. Good distinction there.
Okay, so once you come in here, you can download the CSV report. And in the interest of time, I have already downloaded this report. And since you saw that it has 78 columns and then some more coming from the other dimensions, it has like a lot of columns. So it's not very productive to look at that CSV in this kind of a forum. So what I did here is I've created a small Python program which you can actually feed in your own cost and usage report as well. Most likely it will work because they are all of the same consistent column names and format, right? So in this case, I've downloaded the cost and usage report with the split cost allocation data and all those tags enabled and everything. And there are some columns that are immediately of interest to you in this report, right? You can take a look at your account ID. You can partition the cost by accounts. You can further partition it by region, like you may have certain clusters in certain region, like prod and dev. And then you can also have the product name. In this case, it will be ECS, right? And then a few other items where you have the actual split cost. We also split the unused cost on a machine, which we'll talk about that too. And here are your tags. Remember, I told you every tag becomes a column. So the ECS service name has become a column by this nice colon separated resource tag over here. Okay. So now once you have this loaded, you can actually filter it with the account of your interest and things like that. And you see the data on this actual CSV is quite big. That's why I did not open it. It would probably hang on
90,000 lines.
and 205 columns. Just
so just to understand why there's so much data, I imagine each EC2 instance is emitting maybe like minute granular data about the utilization. So you have like a line for each minute from each EC2 instance, or how's that working?
It wouldn't be at the minute level. The lowest granularity that the report will go into is the hour.
Oh, hour. Okay.
It's,
all right.
It's by the hour. That's the lowest granularity. But what this report will have is not just ECS data. So the reason why it's this big is because it's your usage across all your services across for that entire account.
Oh, I see.
ECS might be one service, right? ECS and EC2 might be two services out of the full workload that you.
So Arvind probably also has some DynamoDB and some RDS and everything else on this account.
I actually deployed a chatbot from some cloud thingy, so I got a lot of things going on there. So you can see that's why I immediately take this data and I by a few things, right? So there is is this me? No, not me. All right, so I have filtered it by things like which product I'm interested. Well, I'm interested in Amazon Elastic Container Service. What line items I'm interested? I'm interested in ECS tasks, that too, just for ECS EC2, right? Because I have some Fargate running as well. What else uses type I'm interested? vCPU hours, GB hours. So I have like filtered this out by the account ID, region, what service and what line item I'm interested in. That makes it a lot more tenable over here. And I've also reduced the columns. I said, hey, I'm not interested in everything. I'm just interested in these columns, 13 of them. So I've essentially reduced this table into a more manageable, about 2000 cross 13. Okay. And if you want to take a sample at what are we talking about? What are these guys talking about here, right? So we can take a look at some sample data inside of it. And you can see this is my account. This is the region where things are running. This is the ECS service. The task is running on EC2. It's running on this particular instance. And here is the new feature, which gives you the cost allocated per task. So depending on how much this task has reserved or how much the task has used, maximum of the two, we will calculate the split cost. Okay.
Wow. So this is based on, I assume, the hourly cost for that EC2 instance. And based on the size of that container that was running on the EC2 instance, whatever percentage of the EC2 instance was consumed by that task is going to be taken out of the hourly cost. And that's how you end up with that fraction of a cent cost for that task for that hour.
Either consumed or reserved. So
reserved.
One vCPU and use just half a vCPU, but you're going to be attributed the one vCPU because that's what you reserved.
And so then unused cost would be the remainder of the EC2 instance that
Remainder.
wasn't even reserved. It was just sitting there wasted.
Yeah, as in like it's attributed to each one of these tasks proportionately that were on that machine, right?
Okay, so if I had 2 tasks running on an EC2 instance and there was a large chunk of unused capacity, the unused capacity would be split evenly across those 2 tasks.
Yeah.
Wow.
It won't be even. It'll be proportionate. So depending on if one of your tasks used more than the other, then proportionate to how much you used or reserved, the unused cost, based on the unused capacity, will be now associated or allocated to your task. So essentially, you have two cost metrics that show up. One is what we're calling a split cost, which is just based on allocation, based on usage or reservations, and then one is unused, which is, well, the box wasn't used very efficiently, so somebody's got to pay for it at the end of the day. And we're allocating that back to the individual task or to the individual workload.
Right. That makes sense. And so we consider that task that was running on the EC2 instance to be the guilty one that was keeping that EC2 instance there, but not fully utilized. It needs to either be using the EC2 instance more fully, or it needs to be running on a smaller EC2 instance.
Yep. And you can see that from the data, if I get my number of instances, I can get the number of instances that we're running over there. I can get the usage metrics by GB hours and vCPU hours. And here are the 2 services that are running, that I have it running, right? Like I just printed the service names. Now here's where you start understanding the breakdown of the cost. We said that's what we promised, right? So before all of this split cost, all you would see is this top of the line bar. Like these are your total number of instances that are running every hour. So that's the cost you would see every hour, right? You got 5 instances running, M5XL. You'll see the 5 cross cost of that M5XL. But now you can see the granular breakdown by, okay, ECS demo backend is using this much, ECS demo front end is using this much, or reserved, either using or reserved, right? These 2 can be attributed to those departments, but look at the wastage over here, right? Like I should really be accountable for why are you allocating this big of a machine if you are really not going to be using it, right? Maybe it is a result of a scale out and it hasn't scaled back in, and that often happens to be the case that, hey, some service jumped up and scaled out the capacity. The service itself has scaled down, but the capacity is still lingering for some reason. Yeah, maybe it's fragmented distribution of tasks and things like that. So you'll often see this kind of like immediate, like, oh, hang on one second, why is there so much unused over here, right? Like I need to bring this down. Let's resize our instances. That's number one. And
and just seeing it like this, it immediately becomes obvious that you're paying more per hour for unused capacity than you're actually paying for used capacity. So
in this case,
I immediately see a cost optimization opportunity there.
Yes, move me to a T3 instance or something like that, right? So that would immediately reduce that. And now if you want to do some more grouping and costing, and you want to do like a charge back and show back type of a thing, you can just do a group by the service name, and you will get a detail about how much did this service cost in that particular time window. In this case, I think the time window is running from 2023, I think about 10 o'clock to here. The next, I think 2 days or something like that, from 7 and 8. Yeah. So in that time window, this was the charge. And you can group by the service and you can have a show back report like, hey, backend, you're using this much. Hey, front end, you're using this much. More importantly, you're wasting a lot. Right? Like a lot of unused cost in the instances that you're running. Okay. One other important thing to note is that in containers, there is a concept of reservations, right? So it is also a good idea to take a look at how much is the actual usage versus reservation. So if I'm going to come back to that.
So I guess just for people who aren't familiar with this concept within ECS, your application container can ask for, let's say, 2 CPU worth of compute capacity. Yeah. But then maybe it doesn't actually get that much traffic, so it's only using 1 vCPU. Well, it would still be reserving 2 CPU on that instance, and so that 2 CPU would go into its split cost.
Yeah.
But maybe it's actually only using 1 CPU worth. So exactly. It's still that's another type of waste.
Yep. this is precisely what is going on in my environment, since it was meant to illustrate exactly the point. I have two labels over here: actual usage and reserved usage. Actual usage is the dot, and the reserved usage is the dashes over here. You can see that my development team has gone a little bit overzealous and reserved quite a bit. 2 GB of memory when they're really using less than 0.2. You can look at the CPU hours, 1 vCPU, and they're barely doing anything, like 0.1, right? This is a bit more alarming of a thing. Usually the gap might be smaller, but it is important to pay attention that whatever you are reserving actually goes and incurs immediate cost, because the ECS scheduler takes reservation into account. It will put the task only when that reserved quantity can be guaranteed, right? And if you can't put the task, it will also trigger auto scaling, and a new instance will come up, and the reservation amount will be guaranteed, and you'll be like, why is that single task running in that giant machine there, as is my case, right? So many factors can cause you to have underutilization. One is the size of the machine as compared to the load and the need of the resource. The other is this reservation versus actual usage. And now, just looking at the cost data, you are able to compare what is going on with the actual versus reserved. Okay. By the way, all of this is available in the columns of the CSV. So if you're not familiar with Python and all of that, it doesn't matter. They're all available in CSV, and I think Shubir can show the Excel variant of this. Okay.
Yeah.
And then this data is all, as I said, like remember all that resource ID and granular thing that we enabled. So if you look at this hard to read human unreadable format.
Yeah, I was turning my head there a little bit, trying to figure out what I was looking at. There's some kind of really long string.
Yeah, that's just the task ID and the ECS service. So what it is that per task, like for example, let's say you saw a sudden spike in a certain time window, and you're interested in what is going on in that time window, which tasks are bumping up the cost over there. Let's say you knew that it's this service, but you want to see what happened, like which task is all of a sudden spiking up. You can get a granular task level breakdown as well of how much they are using and how much they are not using.
Now this brings an interesting idea to mind. Something I've seen before, where you actually push some bad code to production, and the containers are just crashing over and over. And in 1 hour, it manages to restart like 70 or 80 times.
Yeah.
How would it split that cost? If it's doing an hour buckets, would I then see that for that hour the cost would be evenly distributed across like 70 or 80 tasks? And then I imagine on this chart I would see a huge orange bar that would show me that this service has an incredible number of tasks within that hour.
Yeah, that's pretty much what would happen, right? Because and it all goes back to which service that task is associated to. So you're probably more interested in not the task level cost, but the service level cost.
Yeah.
So if that service has a task that has restarted 70 times, more likely than not, there's going to be instances where there was more unused because the task was restarting and there was nothing used.
Yeah.
So it's going to be a mixed bag of when the task restarted, it used some capacity, but then it crashed, and then it restarted, and then while it crashed, the box was basically unused. So it's going to be a mixed bag of usage and then a lot of unused while the system was trying to reboot itself.
Yeah,
that's really interesting.
Well, ideally, this should not happen. Like, I know this topic is on cost management, right? But also I'm looking at the observability of ECS. So we're trying to make ECS really self-healing, like smart, right? But if things like, Nathan, you mentioned, we should be able to catch it, stop before the bills come up, like huge bill, right? So, but that's a good question. Definitely we want to be, if a situation like that happens, we're trying to build more capabilities to be able to catch earlier, send a notification to avoid big bills.
Yeah. We don't want to catch it before it shows up on the bill, but just in case nobody was on call, nobody was there to fix it. I can imagine you would be able to see that on the bill. You would see the large number of tasks.
Right.
Like,
well, we're looking to.
I know I need to fix that.
Yeah, we're looking to add in sort of intelligence, right? Like either send a notification, make it more actionable, right? Like, or maybe ECS will be able to take sort of different patterns, and then we're thinking about like machine learning or So I think we're talking about ChatGPT or generate AI, right? Like if we can see the pattern and take action for customer when customer's sleeping, that would be great, right? But maybe that cannot happen. We have that ambition, right? We're working towards things like that.
You heard it there, folks. A little preview from our own product manager on ECS as to what we're trying to do to make the observability better and
yes, right. Yeah,
detection of errors.
Exactly. And I am also happy to share the top secret that because we talk about like cost management, cost optimization, right? This topic is cost management, but at the end of the day, we want to optimize cost. So top secret is actually all the data for the cost management and then the cost optimization, something we launched late last year for ECS Fargate, coming from the same sort of data engine, right? At the end of the day, any cost management tooling are really about observability, right? You observe your CPU, memory, metrics, and data, and you aggregate, right? So some of the patterns or how CPU memory behaves, you can see on CloudWatch, which is more for DevOps. If I want to monitor your workload, I want the performance tuning, right? Now this we're taking from different angle, from cost management angle, right? Bringing into AWS sort of cost manager or cost explorer or the insights here to really give not just DevOps but also FinOps, right? From there to make their job easier, right? So that's so the secret is like we're relying on the same data, but we are bring that experience for customers. So it make it easier for them to do whatever job they need to do.
Oh yeah, and when you say customers, the thing that immediately comes to my mind is developers, because
right.
I come from a developer background. I like to be the one who's out there writing the code, but so often, in my own case and in many of my colleagues' case, we're not necessarily familiar with how much resources our code actually uses. So when you bring in the observability integration there, it can be actually the case that I write code now and it generates a container. My code's running in that container, and now I can get back information about how wasteful my code was. And then that tells me I need to refactor this code as a developer because the code I wrote is terrible and it's wasting so many resources and it's costing the company way more than maybe the value of that code running is. So that's a good feedback that leads to developers being able to write better systems and sort of close that loop all the way around from DevOps to the financials to the developers themselves writing that application code.
Right. Yeah. And that definitely makes sense. And I think in the other scenario, we haven't had a chance to build demos, but for you talk about as developer, if you break down monolithic application to microservice, there's different way of doing it, right? You can break it into 100 versus 10 versus 5, or you break, architecture different, right? So I think with the cost management, that give us the possibility you can try different models, see which one actually works best from cost management point of view, right? Or you choose different capacity provider, or I only do use this capacity provider on this service task for this period of time, right? So now you have basically more option to look at a different configuration or even different architecture, how the costs will be reflected, and versus what's not. So probably down the line, if we're seeing more, if we get to know more customer use cases, and we can showcase here with customer, and we love to hear others how they use this feature. Bring a lot of creativity with the data and with the tooling and the capability we have here.
Yeah.
So let me just quickly recap. All the things that you need are also put in this nice GitHub page. They're also in our docs. As I said, first, you should make sure that your services are tagged and you propagate the tags. At least enable the managed tags, right? Second thing is you got to go enable the split cost allocation and hourly granular data. That'll be good, right? And then once you have done that, activate those ECS managed tags in that billing dashboard, right? So that the tags are actually used in costing. Then there are some more additional ones that are more on the end of if you have your own custom AMI and custom Docker images, and there's a little bit more there. But once you have all of this, and if you are inclined more towards Python and Jupyter Notebook, then you can use the notebook is available here as well, the one that I showed. Otherwise, Shubir, you can show maybe a little bit about the Excel and how the Excel pivot table looks over there too.
Yeah, that's what I was thinking. The Jupyter Notebook is great for your data scientist or your developer, but what if you're a little bit more on the the financial side or the corporate side? Let's see if we can bring up Schuber's demo.
And I do want to call out the
Yeah.
make sure the last pre-configuration, a prerequisite, you make sure you have the right AMI version, the Docker version, and also and remember the data we're using, coming from you. Like customer need to send us metrics, right? If not, we have to use whatever you actually use. Like we don't have a baseline, right? So there's if you read the documentation, which shows you have to in the ECS agent, there's a configuration. I think it's ECS agent disable metric. By default it's it's false, so you will be sending metrics. But if for whatever reason you turn on to make it disable, then we're not going to get the metrics that can either not give us the data, so we cannot give you accurate data to populate cost management. So I want to just call out, watch for those prerequisites.
All right. So if I understand correctly, you may be running a really old version of the ECS agent in an old
old Docker. Yeah.
And so it won't have the capability to actually generate this data to send into the cost of billing system.
Yeah, that's one. And also there's a configuration agent as well. There are two things: the right version. As long as you have the latest AMI, I forgot detailed version, that should give you the latest Docker version as well. And also make sure the configuration is set use a default. Like most of the time, I think customer use a default. But in case you don't, be sure turn on if you want to get the cost data.
Cool. All right, let's take a look at this Excel that Schubert wants to show here.
Sounds good. So I guess the data that I'm going to be showing you is very similar to what Arvind just talked about. Essentially, he exported the curve as a CSV, and he shared the CSV with me. Just gonna quickly flash this. This is the 205 columns curve that you're looking at. Essentially, it's a matrix, right? It's a set of columns and a set of rows, and it's data, right? And the intention of what we wanted to do with this launch was transparently give you access to data, right? So we can basically add value to that data. What we're working on still is how do we provide you with the right visualizations, if you will, so you can actually, not have to parse 205 columns, and you get these insights through tools like Cost Explorer. So that's one of our roadmap items to make sure that this integrates with Cost Explorer, so you have a visual experience for this. But for now, just for demonstration purposes, I'm just gonna, a lot of our customers actually use Excel. Some of them use QuickSight, right? But you can essentially use any visualization tool of your choice, and it's a very common pattern for customers to take the curve and essentially integrate it with their financial reporting purposes, right? And then use whatever tool of choice they need for their visualization. So we're just giving you an example of what can be done with this data set today. So essentially what we've done out here is kind of replicated what Cost Explorer did. So in this particular view, you're kind of looking at, you've limited your data to EC2. So I'm only looking at EC2. I've also limited it to just one running day. So obviously this is, you get this data by the hour for the entire month and then months to come. But, I've limited this to just one day. So that's 24 hours of data. And then I've limited it only to the 4, nodes, EC2 nodes. And you can see that, here are the node IDs. And then it tells you also what type of node it is. So as Arvind talked about, these are M5 X large nodes. They've been running for 24 hours because I've just limited this data set to be 24 hours only. And then the cost of each node, right? And this is just typically what you would do today pre-launch, right? So this is probably the level of granularity you would have pre-launch, where all you would have is, what is the cost of my running node, which is $4.61. So then for that 24-hour period, your cost for those two services that Arvind talked about was $18.43. Now, the important thing is, as we look at bringing some of this data in and allocating it down to an individual task, we want to make sure that we keep the consistency so that the allocations will sum down. And then when you sum up the allocations, they need to sum up to the cost of the EC2 instance. That's an important consideration, right? It's net zero, right? It has to be net zero, essentially. So, essentially what I'm going to be showing you is how these $18.43, which is the cost of your running instances, translated down to the cost of the 2 running services. And you can go down to the cost of the 2 running tasks as well, if you want to. So what I've done as part of this Excel is I've already demarcated the 2 services. So you see 2 different tabs out here. One is ECS demo front-end cost, and the other one is ECS demo back-end costs. And the way I've done that is I've essentially used the tags that Arvind enabled in the cluster. So you see that I have 2 tags, ECS cluster name and ECS service name. And I can see a list of all my services, right, that belong to that particular cluster. But for the purposes of this, we're looking at two core services, if you will. So I've filtered this down to just the front-end service. And now for that front-end service, I have visibility into what nodes that tasks for that service ran on. So I have 3 nodes that this service ran on for the last 24 hours. And I know the specific task ID. So this is the ARNs of the task, and that's the long string that Arvind was showing you earlier. And then you have the split of the task by how much memory the task used and how much CPU the task used. And you can go down to every hour, right? So in this case, this is looking at it for the hour, for the day, if you will. But you can go down to every hour within that day if you want to get down to that level of granularity.
And how does it split the cost on CPU versus memory? Does it just decide an arbitrary ratio of like memory is worth this much of the EC2 cost versus CPU is worth that much?
Yeah, that's a great question. So essentially what we've done is we've used the Fargate pricing, right? Which essentially looks at, CPU is on average 9 times as expensive as memory, right? So we kind of use that ratio, and using that ratio, we come down to a unit cost of a resource on board of that instance. So if I've got, in this case, I've got 4 CPUs and 16 gigs of memory, what is the unit cost of a CPU and what is the unit cost of memory, right? And then we apply that ratio to say, CPU is 9 times as expensive. So it's basically a price-based split, essentially. And that's been one of the questions that customers have asked is, it's great you can do a price-based split, but what if I want to do a workload-based split, right? What if I have memory-intensive workloads, and to me, memory is more expensive than CPU because my workloads are memory-intensive. So that's another area that we're exploring, where how do we make these weights, which are today static, a little more configurable, that are governed by workload and not by price.
Yeah, I can see in the future, and especially right now, there's a lot of interest in machine learning. A lot of people who are doing like GPU core might be the thing that's expensive that they're most worried about. Or with the new like AWS Inferentia machines, the AWS Neuron underlying hardware accelerator, that's the expensive part to them that they're most interested in. So I'm gonna be super interested in how that customization works out going forward.
Yeah, no, great question. Thank you for bringing that up. So just to follow up on this, so for each task, you basically have a split of how much you actually used, and you can see that the actual usage is relatively small compared to the reserved usage. And the reserved is large numbers because it's running. So it's basically GB hours and CPU hours. So it's running for the entire day. So you can see that the reservations that Arvind had made was, 2 GB and 1 CPU. So it's 24 CPU hours and 48 GB hours. So that's the reservation that was made. So obviously we've reserved way more than we've actually used. And then we've got the split cost and the unused cost that we talked about earlier. So the split cost is based on the maximum of the actual usage versus the reserved usage. In this case, you're always paying by reservation because you've reserved more than actual. And then because the box itself had 4 CPU and 16 gigs of RAM, you can see that for this day, we've only used 3 CPUs, 1 for each task. And we've used only 6 gigs of RAM because it's two reservations per task. So you've really got 1 full CPU, vCPU, and you've got 10 gigs of RAM just lying waste on the box. And that the cost of that wastage essentially got reallocated back to each individual line item. And you can see that in some cases, like this particular task, I think, or this particular instance was, I think, shared across both the different services. So there's some sort of a shared cost out here. but there's unused cost and then there's split cost. And if you look at the cost, so you got $2.92 of split cost for that service as a whole, and you got $6.29 of unused cost for the front end service. And then similarly, you've got, these workloads are pretty, simple workloads. So it was kind of an equal, usage and equal split. But if you were to sum up the split cost and the unused cost across those two services, that essentially would be the $18.43 that the cost of the instance was. And that's really for us, that's our definition of done, right? I mean, we have to be accurate. We cannot be creating dollars out of thin air.
No. Nobody wants that.
Nobody wants that. So, what you've paid for in your bill is essentially how you're seeing that now being allocated down to individual services or individual teams. And that's the value that we're providing on top of that data.
Wow. Well, as we run up on an hour here, we're going to have to hand it over to the next stream show soon. Any closing thoughts about this feature? Things people should keep an eye on? Plans for the future, places where they can offer feedback?
Yeah, definitely. We love customer to give us feedback, ask question on the I think the roadmap we have. We can give it a link on the GitHub. All the containers, including ECS, EKS, all the we have a GitHub link. You can also reach us, right? I added my tag, and I don't know if Shubha mentioned we are right now. You have to use a few different tools, right? We show the Jupyter, the Python tool, or the Excel sheet, but down the line we're looking to have that integration with Cost Explorer, which should be making life easier. And then also I remember earlier we mentioned a few tags you have to configure tags. We understand that some of the are too much manual work, so we're looking to make it more some sort of intelligent default for the customer. So those are also on the roadmap as well.
Yeah.
Good to know. And I just posted a comment in the chat with the link to our public roadmap, so you can request features and additions to the product. A lot of these things like this cost breakdown really come from feedback that was posted on that public roadmap on GitHub, and that leads us to developing more features for you, the builders. Thank you so much, everyone, for showing this demo today, and hopefully folks have learned a little bit more about how to figure out how much their services are costing and how to charge that back to the teams and the services that are running inside their clusters.
Yeah. Thank you very much. Yeah.
All right. Thanks, everyone, and I'll roll the outro.